Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, continuing on with our functions and calculus questions from Leaving Cert Ordinary Level, let's take a look at question 5 from the 2018 paper. The diagram on the right shows the graph of a quadratic function f. Write down the coordinates of a, b and c. Okay, so when you're reading coordinates of a coordinate plane, you read your x coordinate first, which is how much you go left or right, followed by your y coordinate. Okay, so x before y in the alphabet, x before y when you're plotting points. Okay, so a. So I don't go over or back at all on the x plane, and then I go up to 6 on the y axis. Okay, so 0, 6 is a. B, then I go over to -2 on the x-axis, and I don't go up or down, so it's -2, 0. C, I go over 3 on the x-axis, and I don't go up or down, so 3, 0. Okay, show that the function can be written as f of x equals -x squared plus x plus 6. Okay, so there's a few different ways of doing this. Yeah, so solely depends on, I suppose, how you see it. Okay, one possible way of doing it is to show that all of these points satisfy these equations. Okay, so in other words, by showing that they satisfy the equation, and I'll show you what I mean by that in a minute, it means that the points are linked by a function. Okay, so A is the point 0, 6. We're going to feed it into -x squared plus x plus 6. Okay, so label your point x, y. Okay, and I suppose for completion, I'm going to write down the f of x part. Okay, f of x equals. Now, what I want you to always remember in functions is that f of x is y. Okay, so your y coordinate in this case is 6. So this function is going to be equal to 6. Okay, so whether I put it 6 equals the function or the function equals 6, it doesn't matter, it's the same thing. And then I'm going to sub in 0 for my x. So it'll be -0 squared plus 0 plus 6. And I have to show that that's equal to my y coordinate, which is 6. So 6 is indeed equal to 6, so that point works. Okay, let's check the point B, which is -2, 0. So that'll be -2 squared plus -2 plus 6. And in this case, it needs to be equal to my y coordinate for this one, which is 0. So I want to know, does that sum up to 0? So I'll have -2 squared is 4. -2 plus 6 is at 0, -6 plus 6 is indeed equal to 0. Okay, and C is the point 3, 0, x, y. So sub in your x value, so I'll have -3 squared plus 3 plus 6 equals 0. The brackets are very important here. 3 squared is 9 plus 3, so that you get your signs right. That's why the brackets are so important, okay? So try and put in your brackets. So -9 plus 3 plus 6 does indeed give you 0, so that point satisfies the curve, okay? So show that the function can be written as f of x equal to -x squared plus x plus 3. Because all points satisfy the equation, it can be written as such. Okay. Now, perhaps a better way of doing it is to consider the roots of the equation, okay? Because from the roots, you can always form the quadratic that will create those roots. Okay, so what do I mean by the roots? Well, the roots are where it crosses the x-axis. So for this one, x is equal to minus 2, and the other root, x is equal to 3. Okay, now write those as factors. Okay, so bring over the minus 2 over this side, and you'll end up getting x plus 2. Bring over the 3 this side, and you'll get x minus 3. Okay, this is a sad face. Do you see that? So it's going to be a minus x squared function. Okay, so that minus can go in there, or you can change the signs all the way across at the end. Okay, so I'm going to leave the minus there for now, and let's multiply. So it will be x by everything in the second bracket, and then I go back for the plus 2 by everything in the second bracket. So minus x by x, x squared, x by minus 3, minus 3x, plus 2 by x, 2x, plus 2 by minus 3 is minus 6. So let's tidy it up, x squared minus x minus 6. Okay, now let's ripple through that minus, and what it'll do is it'll change the signs all the way across. Okay, and that's how you end up with the function at the end. So you could have got this, and then you could have changed the signs all the way across to make it look like this. It would have been perfectly fine just to do the minus here at the end. Okay, so what did I do there? I used the roots of the equation to form the quadratic. Okay, it's like a backwards quadratic. Often we get the quadratic and we have to solve it. Okay, so you factorize it and then you solve it. In this case, they gave us the answers, which are the roots, and we had to form the quadratic. Okay, there's a third way that can be done, just in case anybody knows it, and that's with simultaneous equations. So again, any quadratic can be written as ax squared plus bx plus c. Okay, so if you get a series of points, which is 0, 6, b, which was minus 2, 0, and c, which is 3, 0. You can use simultaneous equations to figure out, well, what is the a, what is the b, and what is the c that links these 3 points together. And you do that again using x and y and labeling all the points. Okay, so let me show you how to do it. Let's do the first one here. So a stays a. I sub in 0 for the x's. B stays b. I sub in 0 for the x plus c, and of course it's equal to the y value, which is 6. So a times 0 is 0, b times 0 is 0, so I get c is equal to 6. So straight away I figured out one of my values in my quadratic, and you can see there's the 6 that I've just figured out. So now let's figure out the a and the b in my quadratic. So I can write my quadratic now anymore as ax squared plus, I'll just move it down a bit here beside the 6, ax squared plus bx plus 6. Okay, so let's continue on and let's do some more. So let's sub this point into the quadratic again. So I end up with a times minus 2 squared plus b times minus 2 plus 6, and that is equal to 0. Okay, see, I'm using the 6 for c now rather than c because I know what it is. So a times minus 2 squared, so minus 2 squared is 4. So I have 4a minus 2b plus 6 is equal to 0. To bring the 6 over this side, so I end up with 4a minus 2b equals minus 6. So that's my first simultaneous equation with a and b in it. Okay, so let's do it again. So sub it into this again with this point, 3 and 0. So x becomes 3 in this case, plus b times 3 plus 6, and it's equal to the y coordinate 0. Okay, so a times 3 squared is 9, so that's 9a, plus 3b plus 6 equals 0. Bring him over, and I have 9a plus 3b equals minus 6 again. And that's my second simultaneous equation. Okay, so now let's bring the two equations together. So I have 4a minus 2b equals minus 6, 9a plus 3b equals minus 6. And you know you can cancel the x's or the a's or the b's in this case. I think I'll cancel the b's, bring them up to 6. So I have to multiply the bottom one by 2 and the top one by 3. So let's do that. 3 4s. 3 4s are 12a minus 3 2s are 6b equals minus 18. 2 9s are 18a plus 3 2s are 6b equals minus 12. Okay, so plus 6b minus 6b, they always have to be different signs. They cancel to 0, which is exactly what we need. We've 18 and 12 is 30a equals minus 30. So let's solve that. Divide by the number in front of a. So a is equal to minus 1. Okay, let's take that now and solve for b. So you can sub it into either equation. It doesn't matter at all, whichever you think looks the easiest. I think they look kind of the same. So I'm just going to take the top one. So sub in the a you just found, which is minus 1. 4 times minus 1 is minus 4. Minus 2b is equal to minus 6. Minus 2b is equal to minus 6. Bring him over, or plus 4 to both sides. Minus 2b is equal to minus 2. Divide by the number in front of b. So b is also equal to 1. Okay, so the last step then is to fill in my a and b into your equation so that you end up with a, which is minus 1 or minus x squared plus x plus 6. Okay, which is of course what we were asked to show that it was. Okay, so it's a longer way of doing it, 3 different ways of doing that one. This one I think is probably the easiest if you understand how the roots give you the quadratic. But yeah. Okay, part C then of that question. Show using calculus that the maximum point of f of x is 0.5, 6.25. Okay, so that's a key word in calculus. And you have to know that at a maximum point or a minimum point, dy dx equals 0. Okay, so that's the theory you have to know to find max-min points. Okay, it's super important. Okay, so calculus of f of x. So let's write down f of x. It was minus x squared plus x plus 6. Let's differentiate. So dy dx, we have to differentiate so that we can let it equal to 0 to find the max-min point. So to differentiate, take down the power, so the minus stays there, so minus 2x. X goes to 1, and of course 6 goes to 0. So we are getting minus 2x plus 1 for dy dx. Okay, so at max-min, dy dx is equal to 0. I would always write that down in my question. So there's my dy dx, let it equal to 0. Okay, so bring the plus 1 over the other side and it becomes minus 1. And divide across by minus 2. And I'm getting x is equal to a half, which is of course 0.5. And that's what I would expect to get given that there. Okay, so that's my x coordinate of my max-min point found, and it's told me it's a maximum point, so it's 0.5. Now how do I find my y coordinate? Okay, so to find the y coordinate, you sub your x point back into f of x. Remember, I always said f of x is the same as y, okay? So that's how you find your y coordinate. Okay, so y is equal to minus x squared plus x plus 6. So when x is equal to a half, like we have, what's my y point? Well, it's equal to minus a half squared plus a half plus 6. Okay, so let's put that all into the calculator and see, do we get the 6.25? 0.5 minus a half squared. And you get 25 over 4, which is indeed equal to 6.25. Therefore, max point is x, sorry, I'll write it in decimal, 0.5 comma 6.25. Okay, so that's it proven.
If you are interested in technology or engineering but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in electronics and self-driving technologies, and from there to the Masters.
Check out the link below for more information.